Hey, good morning. Can you all see my screen and can you hear me okay? Could you please type here okay and see my video, my screen? Hey, good morning. Can you all see my screen and can you hear me okay? Could you please type here okay and see my video, my screen? Hey, good morning. Can you all see my screen and can you hear me okay? Could you please type Thank you. Here okay and see my I'll just wait for another minute and then I'll start. Just wait for another minute and then I'll start. Just one moment because wait for another minute and then we are I'll also start. Doing live stream on other channels, so I will go and control the sound one sec. Just one moment because wait for another minute and then we are also doing live stream on other channels, so I will go and control the sound one sec. Just one moment because wait for another Okay. I believe you can still hear me. So if you are here for the first time, can you type first time on the chat box, please, or FT? Then I can start the session. Thank you, Shruti. Hello, Akshay. I welcome all of you. Akshay, Barshesh, Chaitanya, Rahu, Rohini. Sorry, I won't get interrupted with the chat, so I will just stop now and again, and then I'll go and answer the chat. So if that's all okay with you, then yeah, we all are first time. Monica, Shruti, first time. Thank you, thank you. Uh, yeah, Basaju, good morning. Thank you. Great. Okay, so let me start. So may I know why are you here mainly? Is this one of these four reasons? Is it to get a job, or you are here to learn a new skill, or if you're already in the industry, you want to upskill, or if you want to do a freelancing or an entrepreneur? Could you type, yeah, Akshay, yes, that's good. Basaju, yes. Rahul, upskill, thank you. Great. Numair, thank you. Basaju, that's great. A lot of you are putting I'm just reading this one sec. Embedded systems and enhance my skills. Monica said, that's lovely. Shruti said, yes, to get a job. That's lovely. Okay, that's great. So I have done a recent survey, and then I have come to a conclusion that there are plenty of jobs available for embedded system engineers like you and I, close to home. When I say close to home, it's in India. I'm based in Sydney, Australia, but I have a lot of friends who work in India in the industry, so they do update me on this. So that's why I thought to give you upfront some idea about how you can also continue with this journey so you can land into that job very easily. Okay, so thank you. Keep the chat going on, and I will pause here now and again, and then I'll go and have a look in the chat, and I will try to reply because I got a few things to cover, and I would like to share everything for you today. Yeah. Okay, good. So if for the first time, if you are here, I would like to tell you a little bit about me. I am Marul P. Anbukarasu. I'm currently working as a aged care support worker, looking after the elderly people in the community as they need a lot of help from a lot of people. So that's what I'm doing. But doing so in my other spare time, I also work in the electronics engineering industry as a freelancer. So I do embedded system and PCB design projects on the other side of it, apart from working with the elderly people. So, in a nutshell, I have 20 plus years experience working in Australia in electronics. I also worked in Italy, Singapore, and in India over the years. Like you, most of you all, I also studied in India in Pondicherry University, and my background is electronics and communication engineering. I came to Australia to do my master's in VLSI and embedded systems, and since then I have been working in few R&D companies, and my main forte is in solar and wind energy and in lead acid batteries. And also, I've been part of ATM developments and teller cash registers and point of sale machines. I worked in various applications. So, if you guys want to follow me personally, there is a link, my LinkedIn link. You can also ping me on there, and I will try to help you as much as I can. Bearing that because I may be at work, I may not be able to respond to you straight away, but I will definitely reply back to all of you. Just a little bit intro about A2DG for the first comers who are here, and then I'll move into deep into what I'm going to say today. Okay, about A2DG, we started back in 2020, and we got into the market in I think 2022. Started by my own brother and I. My brother is in India. He's an IT engineer, and he covers all the behind the scenes sort of thing. So we both gathered all around. Well, he's into 30 years experience, and I'm into 20 years. So we thought to put all those combined experience, what we have so far, so that we can give it back to you to at least 200,000 professionals like you, so that you can also set your career like us. And if you're keen to follow us, I'm sure you would. Please do follow us on our Facebook page and our YouTube and our Instagram. I will share you the links. Just one moment so you can go and browse yourself so you know who we are. Just give one sec. So I'm just sharing my LinkedIn page and YouTube channel. If you haven't already followed, so please do click on that and follow us. So because time and time again, we will be running this sort of online camps for you all guys. So I don't want any of you to miss out. So that's why I'm giving it here. And also we are on Instagram as well. Just one sec. I'm just giving the Instagram page. And also, time and time again, in the LinkedIn, most of us, we are all professionals here. I would advise you to be active in LinkedIn and please do follow us because these are all the channels we will be publishing our oncoming webinars. So you all will gain some experience through that. And before I jump into deep into what I want to say, I just wanted to share that. So hopefully, you all wanting to know all about it and learn. Okay, cutting the intro to half, so let's jump in. And please to stay till the end. I will send you a free ebook that's related with electronics. Basically, that will give you a start if you want to revise yourself in electronics, and this would be a good book. So I'll send it to your email at the end of the session. So please to stay till the end. I got a lot to cover. Hopefully, Zoom will let me to cover the whole lot because Zoom is timed. So that's why I need to be in a hurry to explain everything. Okay. So, pathway to your career. Some of you, even for upskilling, this might be useful for you, I believe. So that's why I put these two links in there, and I'm going to show you in depth about how and all the ways, what is there that will help you. So, in general, when you talk about career pathways, I believe most of you come from engineering background, yes? Could you just let me know what background you're from, please, like in engineering or any field? Because I have covered everyone. Oh, okay. BECE, Shruti, thank you. Akshay, ETC Engineering, Triple E, BTech Triple E, Durga, well done. BTech second year, yes. Monica, ECE, okay. Instrumentation Engineer, BTech Engineering, ECE, lovely, lovely, lovely. So my background is from electronics and communication engineering as well. So I have 22 years now in the industry. So this is what I summarized, and this is the four major hot in the industry. I can divide that into four concepts of software, hardware, project management, and administration. Because these are all really high-paying job, and embedded system design industry is one of the high-paying job. And I will go through what is all about embedded systems in a while, but I'll go through this pathway first, and then I'll jump into little bit about embedded systems today. Okay, so saying that from the career pathways, then we can jump into seeing about what are all the necessary skills being an embedded system design, the skills bank that you got to have, each and every one of you. Starting from one area, maybe starting from technical hard skills. And then while you do prepare your technical hard skills, also prepare your mindset as well, because I have covered in detail about all of this in the coming slides. I'm just giving you an overall view here. And then you can also develop on the other side other skills and soft skills as well. So these are all some of the skills bank that you need to have. So let me jump in and I'll explain to you everything. So are you ready to hear what is career pathway? If you're ready, can you type please ready in the chat box, please? I would like to get some interaction going so I know you're following, so that gives me more energy so I can continue on. Yeah, yeah. Thank you, thank you, thank you. A lot of people saying ready, ready, ready. I love this energy, guys. I'm sorry this is early in the morning for you at 10 a.m., but you are so dedicated here and you are here for a reason. So I'm really, really thank you. And uh, sorry, I'll just clear the screen. Just one sec. Uh, because thank you so much for writing on the screen, but it may be disturbing for other people. So just one sec. Yeah. Okay. So, where is, okay. Okay. Let me dive into deep into showing you about what is that you have to follow in career pathways. I just started with saying there is four major divisions, if you like, in the industry because we are all professionals here. So we can align ourselves into software, or we can align ourselves into hardware engineer, or we can align ourselves into project management or administration. So these four are all evergreen field out there. And I have been part of in all of this throughout my 22 years career, and it's continuing. And thank God, and it is going well. And thank you to the universe. So let me start with the software. What is all out there? You can see. Okay, just one sec. I had to close this. Okay, software, when you talk about software, everyone in the industry call you as a developer, and there are plenty of other names like embedded developer or DevOps or coder, whatever you name it. So developer all fits into that category. So with that saying, so you can also start with, like, if you're really into software alone, like if you want to just be a coding into any language. So there are a lot of opportunities available out there for DevOps engineer, software developer, software engineer, software architect. These are all some of the things that I went across. So I just put it there. There are plenty of other available jobs out there, but these are all some of the um, hot topics out there where you can also focus and where you can also get plenty of jobs. And I strongly recommend you to please take notes. So after this session, you can also go back and compare and also do your own search because most of us, we are all here to upskill and also we need to land into the job. That's my main goal. So please stay tuned and take plenty of notes. That will help you. Yeah, thank you. So I will show you what are all the hardware related jobs that you can consider. So the hardware in the industry, they all group into one big um, division, if you like, as a designer. You can be a hardware designer, you can be a PCB designer, you can be a VLSI designer. So no matter what, anything that's related with hardware, they put it into a category called designer. And I just only summarized only about 10 of the real evergreen wanting in the industry, starting with the electronics design engineer, hardware engineer, and PCB designer. So part of this is the three-part bundle that I'm covering in this series is the starting with the C program, which will cover in the software as a developer, and also jumping from the software, getting into the hardware. I'm also covering one of the microcontrollers, the on-demand microcontrollers, and also PCB designer. So these are all some of the jobs that when you want to look for jobs, you can use this as the title and you can search, or you can use this as keywords and you can also search. And I will show you how to in a minute, but these are all some of the keywords which you can look for because like you and I, we are in the engineering background and this will definitely help you guys. So please take some notes. Yeah. Okay. And then, so I would suggest you to, being from engineering point of view, I would strongly suggest you to maybe start with some software jobs or some hardware jobs. And then once you get maybe 6 months or a year or maybe 3 years under your belt, then you can go and jump into project management and administration. Because as most of you would know, these two involves both software and hardware. So you need to have that industrial experience or the job experience beforehand. So it would be easy for you when you land into project management job and administration job. So that's why I strongly advise you to be a software developer or a hardware designer first and then move into project management. Well, it will all take time. I only able to complete the whole embedded life cycle in about because I took my time. So it took me about 14 years to cover the whole cycle. But I got experience in each and every department. So that's what I would like to share here. So yeah, please start from there. I'll also show what is there for project management out there. See, a lot of us, when we try to jump into the industry, they will put us into a junior project engineer, meaning like companies like Wipro, for instance, TCS. I don't know how the TCS are doing, but Wipro, they're still doing it. They will come for on campus and they will do their interview process, of course, and then they'll put you as a junior project engineer. In there, you will learn everything all about that project and all about what you have to do. And from that junior project engineer, they will put you into software development team or a hardware designer team. It depends of the requirements for that particular project. Then they may change you to associate engineer, which will be more involved with project inputs. Like you will be handled or assigned a task to do, and associate engineer will be part of that as a decision maker, if you like, as well. So once you are more familiarized with junior project engineer and associate, then your title is changed to a project engineer, where um, you will be able to handle a team of engineers to complete a project. You can also call that as a project lead as well, or technical lead. That will all come in project engineer. And once you have few years of experience in that, then they put you as a project manager and program manager. So these are all really like a ladder, which you can start from somewhere as a software developer or a hardware designer, and you can jump into project management. And while you are here, I would like to also show you what administration has to give. Like most of us, we are all engineers, so we all on a daily basis at work, we will be doing a lot of data entry. So even filling up Excel sheets or even uh, filling up a report or filling up a form, that's all considered as a database. So when you consider as a database, there are plenty of opportunities out there as a database administrator, as a system administrator, as a network administrator. If you're into network, like connecting Wi-Fi systems, networks, Ethernet, all of that comes in there. And also a website administrator. If you're more interested when you join in the company, if you want to manage that company's website, then you can also do so. And overall, the office administration to make sure all these four categories are going well. So this is in a nutshell the whole logic behind the career pathways. If this is useful for you, could you please type useful? Then I'll move into the embedded system skills bank, and then I'll go into teaching you embedded system industry. Thank you, Shruti. Thank you, Ahmed. Thank you, Durga. Thank you, Monica. Thank you, Bala. Thank you, guys. Thank you, Jai Chandran. Thank you. This is really, really wonderful. Uh, Sorry, one sec. Okay, so before I go into embedded systems, let me show the embedded system design skills bank where you got to start. I'm sure some of you might have already attended my session before. If you have already attended, I'm so sorry. It could be a repeat for you. But these are all evergreen, so that's why I bring up in my first session to give you a bit of an introduction of the overall skills that you're after. So then you would be able to follow this as well. Okay, so I keep talking about embedded system design. What is that? You will learn all of that in the next coming slides. But before that, I would like you to start setting up some goals so that you can start to accomplish one after the other, and then you will be job ready by the end of these three courses. Okay. So from the engineering point of view, I will start with technical hard skills. So that's what our major area is going to come from. I'll just minimize this so you can also see what's in there. Okay. So if you elaborate technical hard skills, don't worry, don't think there is a lot in there. Eventually, you can be part of in everything, but start with something fresh and then you can learn a lot. So first, we need to start with fundamentals. I know some of you are in thank you, Rathod. I saw you. That's why I saw that. And I'm telling you, thank you, Baddu. Baddu is one of our previous student. He's a very good hard worker and he's been learning a lot. So something triggered him. So he's attending here again. Thank you, Baddu. Um, yeah, okay. So let's start with fundamentals. As an embedded system design engineer, you got to be strong with the fundamentals. Once you're strong in one programming language fundamentals, basically you can multiply that and you can learn other languages very easily because the logic, the principles behind that all same. It's only a different language will have a different a syntax, if you like, or different format. So that only varies, but the logics behind that. I'm sorry, I got to mute some of you. Just one sec. Sorry. Okay. Yes, sorry. Because I was hearing some background noise, I didn't want you to disturb. Okay, so in the three sessions that I'm covering is I'm starting with C programming because all programming starts from C programming. If you ask me why C programming, I learned C programming back in 1998. I know it's a long time ago, right? But that is my foundation, my fundamental. And even now, that C programming, I'm using it in my current projects. So that's how it is. So C programming is the core. It's like our in our 4 years degree, that is our start. So that's why I have given you a lot of details in terms of embedded C programming in my C programming course, which will cover everything, starting from how you can open a project, what are all the things you need for your project, and then we'll go step by step. So, which I don't want to bore. So, be strong in one of the fundamentals, then you can jump. So likewise, there are Python programming, JavaScript, MATLAB, C++. So these are all main five cores. So you can choose any one of these and you can master that, or simultaneously, you can start with C and you can also learn Python or MATLAB or C++, whatever that interests you. Then, as an embedded engineer, when we jump into the industry, when we land into that first job, I'm sure my three courses will help you to get there, but I'm just giving you a brief outline. So, when you get into the embedded C, what is in there embedded C? So, embedded C is an extension of C programming. So, that's why I covered C fundamentals and all related with embedded C. And you will come to know about the first microcontroller, which is 89C51. From there, you will get fundamental ideas about microcontrollers. Then you can jump on to learn Arduino if you want, and embedded system design and IoT. And there are plenty of other courses available as well in the market. But what I am covering is for you to step into the job. So that's why I didn't cover for now all of the other area in here. I'm covering C program and also embedded system design. When you expand this, I'm covering a ARM Cortex-M4 in part of this series. So these are all some of the microcontrollers readily available and also ongoing projects at the moment. Not so much on 89C51, but there are plenty of projects going on in the industry with PIC 8, 16-bit and 32 bits. There are there, and then ARM 7, ARM Cortex M4, and AVR Atmega microcontrollers. And with the artificial intelligence, now it's booming really. We also have ESP32 and Node MCU. So these are all some of the microcontrollers which you can intend to carry on. Once you start with one microcontroller, it's basically you will set the fundamentals right, and then you can easily follow with other jobs. I mean, sorry, other microcontrollers. So likewise, be ready and master one of the microcontroller, then you would be able to follow the other microcontrollers. There are more courses coming your way, but I wanted to start with ARM Cortex M4 because that is on the top on-demand skill right there. I will show you in shortly. Then there is other things like free real-time operating systems, Raspberry Pi, VLSI. That's one of my majors in my master's. So in VLSI, most of you, if you are from VLSI background, you would know ASIC and FPGA. And again, when you go to ASIC, there are front end and back end. So these are all some of the jobs out there which you will be able to have your hands on. And then the Internet of Things is really hot at the moment. So I also covered one of the tool in one of the major project covered ThinkSpeak. There are also Amazon Web Services, AWS, and Microsoft Azure. But I will cover that in a different session. But there is a project that you will learn how to use ThinkSpeak as well. And then you can also, once you're familiarized with that, then if you have more energy, you can also get into embedded AI. AI will be more integrated with Raspberry Pi and Pink and Jetson Nano. So these are all some of the advanced version of embedded. But just by learning embedded C programming and embedded microcontroller, you will land into that 10 LPA plus jobs. There are students from my previous batches who already completed this and then they landed to that job. And even today, I get messages saying it was useful for them. So I want you to be in that situation. So that's why I'm spending my time here to explain all of this for you. Okay, and most of you would be learning MATLAB from your degree, from your university. You will be learning all about the fundamentals. You know how to image, process, signal, machine learning, deep learning. This will all be linked with MATLAB. So just for interest, is any of you learning MATLAB? Can you type in the chat, please, MATLAB? If not, that's okay. That's not part of our curriculum here. Oh, yes, yes. Durga, Monica, very good, very good. You're in the right track. Yes. Nagendra, Shiva Nagendra. Yes, that's good. Okay. So keep learning MATLAB as well because when you come to, as I don't have to elaborate on that, but when you want to do further analysis, MATLAB is the key to have. So combining with the embedded systems and MATLAB, no, it is a mind-boggling skill set that you can have. Uh, Mahesh Bala, that's okay. MATLAB, it's not really hard because it's very easy. It's a lot of others can give you ideas about, so you can chat to them. Yeah, MATLAB is also one of the industry. It is really growing up. And then, okay, let me complete with this, and then I'll come back to the chat. So then also you have the PCB design. PCB design, in my course, I'm covering Altium Designer. Altium Designer is one of the top industry tool. It gets you to work in multinational companies across the world, not only in India. In India, majorly Cadence or CAD and Allegro, sorry, projects are handled in India, and very little of Altium because Altium is an expensive tool for companies to buy. So that only reason, not many companies prefer Altium, but worldwide, like when you join one company in India, you would come across projects coming from other countries. And definitely there will be Altium designer to work with. So that's why I put Altium on the top. And I covered in depth about starting to design a switch mode power supply, how about getting the ideas and how to complete the whole thing in, I think in about 8 days, I covered all of that. So you will learn everything in that PCB design course, which is covered. And also there are other tools in the industry: Cadence, OrCAD, Allegro, Eagle, KiCad, and Mentor Graphics. And I have worked in all of these. So once you know one of the CAD tool, then you would be able to follow the others. So you don't have to worry. Just learn one, and you can follow with the others. And then you can also do your own customized board design. What I say when I say customized board design, meaning you can develop and you can solder yourself. If you're good in soldering, you can also develop and do your own PCB board. Unfortunately, I don't have any PCB boards here right now to show to you, but I will do so in the other classes. So as a hobby, I started, so I developed my own board and I used it as my prototype board and I tested. So likewise, you can also do it likewise. And let me quickly jump into giving you a little introduction about the applications. You can imagine embedded system is in every industry, but these are all some of the hotcake industries. Brain computer interface, something that relates with the artificial intelligence that connects to your brain and you can interface actually, where most of the robotics comes in actual. And then there are now self-driving cars in Los Angeles and in New York. I think the service has already started. In Australia, self-driving car is in the prototype testing, so we will have our own self-driving cars here. So likewise, India also tied up with some companies and they are in the testing phase. You will see plenty of self-driving cars in our roads very soon. And not only that, we are embedded system engineers work in robotics, software-defined radios, medical devices, and industrial automation. You name it. The industry is vast. So I just wanted to cover from start. So all I wanted to give you is the start so you can go and explore yourself. So this is about technical hard skills. Are you are you finding this useful? So if it is useful, please let me know. I can quickly jump into showing the others and then jump into the session. Yeah, yeah. Thank you, Monica. Thank you, Ahmed. Thank you, Nagendra. Thank you, guys. So I won't waste most of your time. Thank you, Rahul. Thank you, Rathod. Thank you. Okay, let me change my. Okay, I change my settings in the chat so I don't miss out any of your messages. Okay, being an engineer, our mindset plays a key role. No matter what projects we use, we have to define our character. So the more you give out, the more you will get back. That's how the industry works, and that's also the universe principle, if you like. So be and have a positive mindset and be in an abundant mindset. So even if you know a small concept, if you are familiar with, please teach that to your friends. Please teach that to your colleagues in the industry. By sharing that, it will also go into your subconscious mind, deep into you. So you will be very strong in your core, in your fundamentals, and that will help you improve your future projects that will come. So mindset, you also need to be more prepared. And when you join our courses, I also cover a lot of mindset activities which you can also follow. And then you can also like teach others in your coaching and give them guidance. Like some of you would be already finished your degree, you can give your guidance to your upcoming engineers in the field. That's also another thing you can do. And parallelly with the soft skills, you by this time you got to start to create your own resume writing, which I will cover in the slides shortly. And then be active in the LinkedIn network. So these days, people, the employers, come into LinkedIn and offer you jobs through LinkedIn. So if you haven't created a profile, please do start creating one, and that's one of the professional network. And then start to do some interview preparation. I also covered that in the slide. In the upcoming slide, I'll show you how. And then be strong in your communication skills, be in verbal or in written. I know I have been in your shoes 25 years ago. I was so shy. I was thinking that, oh, no, I don't know any English and I don't know how to talk to people. That's okay. That's well and good. No one is perfect. So when you start to practice, practice makes perfect, right? So when you start to practice writing emails, talking to other people in English, why I am giving this session in English is because as soon as you step into the industry, mostly English is a widely used form of communication. So that's why I want you to think as a native English speaker as well. So you can also follow with the rest of the project teams. So develop your communication skills and develop your time management skills. So, for example, I set this time at 10 a.m. For you all, so you can freshen up yourself and be on time to attend so that you don't miss out on anything, whatever I say. So, you got to be more manageable with your time, and that will also help in your long run. And be finance control as well. Make sure you are spending your time on valuable things rather than not so important things, because those things you can concentrate later. But you got to invest on yourself first. The more you self invest on yourself, the more you grow, and the other things will follow, which I will also cover. And by doing all of these six things up there, your leadership will start to grow up. So you would be able to be in a position to guide a lot of people. So that's where your leadership skills will grow. And then once you master all of these seven, then you can develop your own personal branding. You can start your own freelancing projects, etc. So that's why I categorized all of these in the soft skills. I'll get into other skills, like you can also simultaneously develop learning about Excel spreadsheet, because in the industry, believe me, even today I got to fill out of Excel spreadsheets and Microsoft Word. PowerPoint creation, yes, that is a must, because as a design engineer, you need to project your work to your senior engineers or to other clients. So PowerPoint is still there in the industry and you should be able to do it. And then editing skills. You can be an editor in your, uh, uh, for example, in your video skills or in your PowerPoint creation. So develop that all these in a nutshell, then you can also be a very good, strong embedded system design engineer. And this is what I summarized everything in the summary, so I don't want to bore you everything. So I explained that in the computer architecture, we got to learn one of the microcontroller, and then we can multiply that and use in other microcontrollers. And then PCB designing, again, there are plenty of tools, but Altium is on the top, so that's why I covered Altium. And then you will learn through that how to be power efficient, power and battery management, etc. So these are all the skills when you start to develop your embedded journey, these will all come to you. So, are you finding this useful? Now, I will jump into talking to you a little bit about embedded systems. So, if it is useful, then I will jump in and show you, continue with my other slides. Nagendra, thank you, thank you. That means a lot to me. I'm happy that you put in your effort to join here and learn through this session. So it not only the session won't stop here, so I'm going to give you more value to it. So please stay by. Thank you, Monica. Okay, that's great. Okay, let me start with today's session of embedded systems. Uh, So, here is the interesting stuff. I'm sure some of you might be seen or known this definition from your study background, but I just wanted to revise as well so you all know what is it all about. So, what is an embedded system? Embedded system, as we all know, we are in the industry and some of you already studied. So, embedded system is a combination of both hardware and a software with some associated mechanical parts. In some cases, they all let to do something to perform a specific task. So in this example, this chip, this is what we are all, I'll play this. This is what we are all trying to learn to program what goes into the chip. And then we're going to do that by learning PCB design to create this PCB like that. And then we're going to learn how to write codes by writing plenty of codes like this guy is doing. And with some mechanical parts, sometimes you need to connect interface things. So all this combined to work to perform a specific task is an embedded system. Um, is this definition useful for you? And if you haven't heard anywhere, then uh, please tell me so I can come up with things like this in the future as well, and I can break into modules and I can explain. Yeah, okay. So I'll repeat. Embedded system is a combination of both hardware and the software linked together with some mechanical parts. Like for example, in embedded system, if you link with ATM, automated teller machine, there is a plenty goes on behind the scene that we won't see. Plenty of mechanical parts involved to perform a specific task, which is nothing but when you put your card in, the card has to take in and then give you money. So that's one example. So likewise, I will give you an example about a desktop. Desktop is not the whole desktop computer is not an embedded system because it has its own operating system and it is a combination of a lot of things. Whereas the embedded systems, what we do on a daily use of this in examples like printer. Printer is allowed to do only one job. Whatever you ask it to do, it will perform. So it is only customized to that job. And also there are other examples I can guide you, like in the washing machine. On the panel, you will go and throw your clothes in and set up a timer and also throw powder and all the detergent liquid in it and then press start. So that control panel is embedded system. And that is allowed or allowing you to perform only rinsing and drying if you use the dryer, etc. So that is meant to use only for one that purpose. And I also given you a microwave as an example. Microwave control panel. Microwave is useful for making food, as you know, and the control panel is embedded. So you program some of the pre-occupied ones. So you go and give the command, and also there is PCB design involved behind that panel, and you'll be writing programs. So these are all some of interesting things that's ongoing. So as you know, when you go to the supermarket, you'll see plenty of microwave on display. So whenever you see next time, you should remember all this logic, what goes behind. So over the years, when you learn about this embedded microcontroller and the PCB design, you could also start your own microwave design, and you can be a manufacturer. It happened. Couple of my friends started, and they all do a lot of manufacturing business. And they work in different major companies now. So you never know. So that's why I want to give you a start so that you can also follow your dream and you will end up where you want to go. So this is about the embedded system. Are you clear with the embedded system definition and the examples? If you are clear, could you type clear on the chat box? I'll move into the next slide. Thank you. Thank you. Thank you. Thank you, Monica. Thank you, Bala. Uh, Thank you, Durga. Okay. Because these are all very basic, you must have already learned somewhere. So I don't want to spend more time in here. I'll just move on. Then we'll get into the classification of embedded system. So there are two major classification in the embedded system. First is the real-time embedded system. And in the real-time embedded system, in a nutshell, if I want to explain, a system that completes the tasks within a specific time, it's called a real-time embedded system. There will be plenty of tasks going on as you land into, even if you're in the final year or third year in the engineering. If you want to concentrate on doing your major project, first you need to start with gathering all your ideas. Then you'll be going to gather all the components. Then you need to decide what programming language you're going to use and what are all the hardware. So each and every concept of that is a task. It's a separated individual task. So all of that happens and has to complete at a certain deadline, meaning you have to produce a project for your final year degree. So that is your deadline. So that is what real-time embedded system is. A system that completes the tasks within that specific time. It's nothing but the real-time embedded system. I thought to connect with you with the project, so that's why I'm giving you that example. But in the industry, it varies. It depends upon the client requirements. The tasks will be divided accordingly, and the team will work on those tasks. Then, when you talk about real-time embedded system, there is two major divisions again. There is a hard real-time embedded system, and you will know the second one. What is a hard real-time embedded system? For example, I shown you a missile and spacecraft. For example, if it misses to get into the orbit, for instance, two of the NASA scientists went to the space, and due to some technical reasons, they were not able to come back in 8 days' time. Their journey, they went for 8 days, but they had to spend there like 285 days. I'm not sure exactly, but things like that, when happens, if it misses the target, then they have to face a lot of consequences. So that's why hard real-time embedded system are more time critical. It shouldn't cause a lot of havoc in your system. So that is one of the uh, hard real-time embedded system. But the second example, that is a soft real-time embedded system. I have given you as an example as a audio and a video software. If you don't see my video or if you don't hear me well, it only degrades this particular session. It's not connected to anything else. It's only for this session. So likewise, behind the scene, there will be plenty of things going on. It won't affect any of the other system, and the other systems will be running, but the quality may be degraded. So that's what two major categories of hard real time and the soft real time embedded system. Then there is what we call as a network embedded systems. No matter what system that's connected with network, then that will come under network embedded system. And I have given you as an example as an ATMs. Yeah, we all want to be that guy who had a graffiti running around the money. Yeah, yeah. Okay, we all know outside, you go in front of the ATM and you put your bank card in and you key in your PIN number and whatever money you are wanting, it will go to your personal bank and then create all sorts of things. So that alone is the whole network embedded system. The minute you ask the money, and behind the scene, it has to check with your balance and all of that. So that is one big example. And I have worked intensively in this network embedded system. And another one, these days we all go out to have our meals to our restaurants, to cafes, ice cream parlors, you name it. So most of the places these days you will see this small machine. You go and tap sometimes, or sometimes you insert your card, and that takes a payment. And that is also another example for network embedded system. And then there is mobile embedded system where the embedded system alone runs on a battery system. You don't have to connect to a main power supply. It can be operated over a battery system. For example, I have given you this GIF with medical instruments like the ECG machine, and when they move patients from one place to the other, it has to be connected with the all the monitoring systems. So likewise, there are a lot of other classifications, but these three are the real main. Most of them will come under the subdivisions of this. So are you clear with this classification? If it is, then I'll move on to the next one. Yeah, yeah, okay. Thank you, thank you, thank you, Monica. Thank you. Thank you, Durga. Thank you, guys. I'm glad you're all following with this, and I'm really, really happy that you're following. I'll move on to the next one. So let me tell you a little bit about there are different processors and controllers in embedded systems. Like you and I, most of us, we would have started from, well, I started learning 8051 back in 1999 as a microprocessor, 8051. From there, other family developed microprocessor changed to microcontrollers. And you will learn everything in that course, what is the difference and all of that. But I just populated here. And then there is digital signal processor, DSPs, and digital signal controllers. These two are the major marketers of those two. And the CPLD, complex programmable logic device, and the field programmable gate array. Xilinx is a big manufacturer in FPGAs, and also Zinc, another one. And when you talk about a VLSI, there is, as I showed you in the front end, there is ASIC and FPGA. So you can also develop into ASIC, application specific integrated circuit. Intel does this movie disk stick. I'm sure there are plenty of projects that's ongoing right now in Bengaluru and in Pune, and Intel mainly focuses in these two branches, and they get freshers out, and you would be put into developing projects like this. So there are plenty of opportunities. And then SoC, system on a chip, and then there is the TPU, which is in Google Coral. Google come up with their own chip, and they what's called a tensor processing unit. These are all some of the process and controls in the embedded systems. Um, while we are talking about jobs, I just wanted to give you a little bit. So in general, when you go to Google, just type in salary range for freshers in embedded systems in India and see what you get. So that's why I put in my ad that you can easily land into a 10 LPA per year job. And see, as a fresher in embedded system, you can expect a salary from 1.3 lakhs to 18 lakhs. I know a few of my past students who are approaching that 18 lakhs now. They all started from low, but they all got there. And also, if you come here in this, and I just want to give you this will be mind-boggling for you. There is a lot of scope in our industry. And after 1 year, 2 year, 3 years, your category will increase, and depends upon your experience, you will also grow higher. So this is in a nutshell. There are plenty of jobs. And one of the job sites I would like to show you is Naukri. This is the one a lot of my previous students also used, and also the current upskill marketers. So if you come in here and if you just use a keyword like embedded systems, embedded system jobs. At the moment, right now, there are 570 jobs available. And if you start to spend the next 45 days in learning all my three courses, then see their experience. They are taking freshers 0 to 5 years, embedded C, software design, embedded software, software development, automation, control system, CAD, PCB. So every job when you go there, you will see PCB designing, RS-232, which I covered in one of my projects, sensors, MATLAB here, and Verilog, SOC, which I covered. And if you come here, RS-232, RS-485, these are all some of the topic that I also covered in depth in my courses. I'm just showing my course are oriented with the industry demand, so that's why I coined all this course. And if you come here, embedded systems developer, embedded C, communication protocols, wireless communication. Yes, one of the project I'm covering ESP32, you will learn about wireless communication. So likewise, there is plenty of opportunities, software engineering and embedded systems, sensors, you name it. So there is plenty. And also there will be interns now and again. So also target these people intern. So 3 month duration where you learn a lot from this company. Likewise. So C, embedded systems, embedded C. So all this, and even if you take your research further, if you go to sixfigure.com and if you type in any job market, so I just typed in PCB design and see the average salary, 23 lakhs per year. And that is a lot for us when we finish our engineering and when we jump into the industry. And a lot of people develop their skills and immediately get 20L as soon as they get into the industry. Not only PCB design, even if you search for instance, embedded system. I will search, for example, as an embedded system, and okay, it's not coming as embedded. Oh, sorry. I just wanted to show you what's out there. See, as an embedded system, the basic average salary is 19.7 lakhs, which is a good start for all of us here. So that's why I want you to be focused and be dedicated and to learn all these three skills. You will also be able to earn all of this. So that's why I would like to show this to you. So, okay, let me move on with the slides. So, um, you are you thinking this session is useful because now we know what jobs are available there and how you can target and all of that. I'll move along and explain few more things in the slides. Yeah, thank you, Monica, and thank you, Durga, thank you, Akash, thank you, super guys. That's lovely. Okay, so these are all some of the programming languages which you can use for embedded system, starting from assembly language, a C program, and there are some projects where you will need to use mixed C with assembly. I have covered that in one of my projects in the course as well. And Python, if you want to really get deep into these days, embedded systems are started with Python programming, and there is hardware description language HDL and graphical and visual. As in terms of MATLAB, you will be using plenty of graphical and visual programming as well. So these are all some of the programs you could choose for embedded system. So here is my time to ask you some questions. Can I? With your permission, shall I please? This will be interesting, so I can ask you some other questions. Thank you, Shruti. Thank you. I would really like to give this offer to you right now. So if you want to have these recordings, there is about 30 days in STM32, there's about 8 days. So C program, 40 days, and then there is the PCB design about 10 days. So you get about 60 days or 50 days worth of video recordings. And if you want access to all these course materials, it will be all very in-depth details. I make into a zip file and I put it out there so you can download it and read it. And also, what I saw from the previous batches is I started with dedicating a separate Saturday session because a lot of them felt like only the weekend they want to spend some time with their family. So I changed from Saturday dedicated session to a WhatsApp doubt clearing session. Yes, you can send directly to a WhatsApp message, and I can be able to clear all your doubts. So if you want to have that as well, yes, there is the option there. And then you will be all linked to join a private WhatsApp group where like-minded people will be there, and we will all learn from each other and we'll grow together. And then I can also send you a roadmap about how you can connect between your links. So this is the deal I'm going to offer you today. So it's a three-part course program, and this is what I'm going to distribute to you. So it's a three-in-one course bundle. Don't get puzzled with this 999 value. That's if anyone who goes to a2digi.com, I'll also show just one sec. Uh, so if you go to a2digi, that's our website. A lot of people coming here and purchasing this. Just give me a sec. Because I'm using a different browser, so I set my firewalls. So if you come across here and if you go to services and courses, you will see people come here and buy directly from us using C program, and all the price list is 14.99 and 14.99, which I'm not going to ask you right now. I'm just giving you what is available there and the offer. So this one will cover all the fundamentals of C program, which is intended to cover all the embedded C, and you have two full day sessions, hands-on programming projects. You will completely learn as an expert embedded C engineer. So you'll be using a DJGPP compiler, and you will also use your DOS command, and you will be writing codes to learn all about it. And then you'll move into learning STM32 microcontroller, which has about 30 days of different sections. You will learn all of this starting with mini projects, and you will learn ARM Cortex-M4 architecture. And I have covered two major projects, one with Bluetooth home automation, and the other one is the IoT and Wi-Fi. So this, most of the people, they'll just buy this from the website and they have to pay 14.99. I'm not going to ask you all of that. So PCB design, this is the Altium Designer, a master class, which you will learn to design from start to finish, SMPS, switch mode power supply. Again, if you go to our website, you got to pay 14.99. I'm not going to ask you that. So you get all of this, you would be able to build 50 plus projects, which is, if you see all of this individually, it will come basically something like 42,000 people are spending that, but actual price, we also give you that offer as 14,497, but I'm not going to ask you all of this. So you get all of this value today, not in that price, but we used to give roughly about 2,500. But because you all showed your interest and you wanted to learn, so for you, if you want to register with us for the next hour, I'm going to give you this deal. So three-in-one bundle, you get all of this that I mentioned to you so far. So you get three technical recorded course videos that will help you to learn at your own pace. If you are going to university, you can come home in the evening, you can learn, or in the morning, in the weekends, that will also help. It has got 50 plus project source codes and materials, all this value. People purchase just this by paying 10,000 to me and I sold it to them. But being you are here already, I don't want to charge you that. So that's why I'm categorizing you to show you. And you get a lifetime private community plus WhatsApp group, and that's value 10,000. And you get three individual course certificates. As soon as you finish one, you'll get a certificate. And all these courses are lifetime validity. And all this, that's our usual price. And today, if you register in the next hour, you got to pay only 14.99. I'll share you the link. So please do make use of this right now and start to invest in yourself. The more you invest in yourself, the more you'll be better at. So I'll just share the link. Just one sec. Yeah, so this is the link. So please go and put through your purchase while I continue with the other sessions. So these three will land you into that 18 lakh per year, which is only a start. I know in my friend circle, there are friends, now I have 22 years experience. So we all earn a lot. We are all in the top scale, which if you do the Google, you will know all about it. So I want you to not to miss out on anything. So please click on that link and please put through your purchase. And some of you from other batches, if you already purchased, then you don't have to worry because it's all included in your pack. So I'll tell you the difference between the 3 days summer tech camp that I'm running for the next 2 days. The doubt clearing session, yes, only in the session. At the end, I'll take Q&A. But if you buy this 3-in-1 bundle course, you will have a dedicated doubt clearing session. You can directly talk to me in WhatsApp, and I will send you either a message or videos to make you understand. And also, today by attending or if you attend all the 3 days, you get a ebook as a participation. But getting the 3-in-1 bundle, you get three different courses. Yes, in some interviews, people our employers ask, did you put any hard work before? And you can show them that you studied really 45 days and you know all of this, so you can prove to them that I have course certificates. Unfortunately, these 3 days going to be live. So recordings for these 3 days, it's not available due to logistics reasons. But if you buy the 3-in-1 bundle course, all these videos will be readily available to you. So once you put through the purchase, can you send me a text saying you bought it so I can let my team know? So you will get your access within 24 hours because at the back end, they have to check all of your account settings, etc. Okay, so I would like to give you a little bit more about how this will help you. Even if you want to upskill, this will be really, really helpful for you. So get the fundamentals of embedded C programming, which I covered in C programming and then in the STM32 microcontroller programming. So you're going to learn ARM Cortex-M4, which is used in a lot of complex projects. So I have digged deep inside explaining about its architecture. In any microcontroller, if you are more advanced to know what the architecture is involved, then rest is easy. You will know which interface you need to use, which communication protocols it needed. So you can start building your own projects. And also, I have covered with an IoT project because that's the hot industry at the moment, doing embedded system in the IoT design. So I have created one project and you're going to use ESP8266 and you're going to link and send data to ThingSpeak. That's another IoT cloud base. So you're going to learn that. And then PCB design, I have also covered Altium Designer. So you will learn to develop your own switch mode power supply. And you will end up designing a board, something like this, which I'll show you just one sec. Sorry, this is in a static bag, so it has to be being electrostatic. So you will be learning to use something like that with a single input and a dual output power supply. Why I covered SMPS is because every project needs a power supply. And when you know to do your own power supply, you can save a lot of money. You don't have to buy an expensive adapter outside. So that will cost a lot when you start a project. So that's how I covered the SMPS board. So this will all cover your expenditure. And then these are all some of the portfolios or the necessity that you can have to land into high paying jobs. Begin with 20 plus projects. So in our three courses, you will definitely get at least, I think, about 47 or 48 projects. So you can combine all of that and create your own portfolio as 20 plus projects. And start, if you are fresh, if you want to get into the industry, get all the ideas and start to put it in a document, say it be 30 to 40 pages or even 50 pages. Then from that 40 pages, you can cut down things and you can summarize into 3 pages. Or for a fresher, it's 2 page resume. The industry is preferred, so you can customize it. And then you can also build your own brand websites showcasing your projects. Like if you have done plenty of projects, you can build a page and you can show all of that in that project. And be active on LinkedIn network. These days, the engineering employers are always in LinkedIn, and they know and they assess your activities, what you're doing, and how efficient you are in the industry. And therefore, you get offers in the industry in LinkedIn as well. But please, the fifth step is really important. Research the company and the job role before you attend the interview. And that will really help you because you know what you're in for and you know everything about what that company is doing and what your role is. And by doing so, this 45 days of A to DG3 courses, I will put you into that stage. You will definitely clear the technical round of the interviews. It's all about mindset. If you just go and crack it, I know a few students already passed, and I put some of the comments later. But you can also be like them, so you can also go and put through that, um, clear that interview, and land into that 6 or 8 LPA to start with. Thank you so much, Nanda Kumar. I will let my team know. They will start their back-end check, and you will get the access within 24 hours. Yeah. Let me continue with this, and I'm sure the others also please make use of this. Otherwise, if you go to our website, that will cost you a lot. But being here, you are dedicated, so I wanted to give this offer to you. And most of us, we have this resistance. I'm too old. I already wasted some of my years, and I have some gaps in the middle, 3 to 5 years gap between jobs. And I can't really understand whether I can get into the job. Yes, you can. It's just your own mindset. You need to be more accountable with what you want to do. Set your plans, and accordingly, you can explore outside. And also, if you don't have any particular skill, go and get into that and start developing that skill. That will develop your technical skill. And fear of failure that comes to each and every one of us. We will question ourselves, what if that doesn't work, what if. Change the if to it will happen. And don't worry about no money. You may not have any money right now, but over the days, when you upskill your knowledge, upskill your technical skills, then the money comes to you and you can be in a position to get everything in abundance. So that's why I would like you to follow these principles. So that will help you to get there. So work on yourself. I'm thankful that all of you, you are here, that you made the choice and you are here to learn and you made the first step. So work on yourself. Self investment is the best investment. The more you invest on yourself, the better you will be at. And always have a abundance mindset. Even little you learn, please try to educate others. Please try to teach others. So you will also be useful, and also it will stay in your mindset. Change your environment. Disassociate with negative people. Don't be tangled into negative people all the time because they will try to push you down. Believe me, nobody wants anyone to grow, because of jealousy and a lot of other things. So always stay tuned with positive people. If you mix with positive people, immediately your your society status for you, your own growth will go up. So always be a lifelong learner. Even today, I buy a lot of courses, I buy a lot of books, and I learn every day. And that helps me in a better position to pass my knowledge, my skills to others. So self-education will bring you the most fortune that you are after. So be a lifelong learner. And you only need some of these courses. So start with an embedded course and a PCB design course, and you can start to upskill. And even if you are sitting in the fence and if you're wanting to change your career, I'm sure embedded is one of the prosperous career, I would say. There is demand all the time. You can also talk with our like-minded people. Once you are in the community, you can also chat to other people. And You can also do it on the side. I'm not, what I mean that is you can also work in some other division, but in the evenings and on the weekend, you can also start to develop your PCB design work, your embedded microcontroller. You can sell that. People have done that in the past. So you can also earn some more money on top of your main category. And once you join, like Nanda Kumar, thank you so much. Once you join, there are plenty of community members that to help you, and they will be texting you and chat with you. So the others, if you haven't made your choice and made your decision, please make use of this deal. And I would like you to get this so you can get started. And I would really, really want to help you. So don't take my word for it, even if you want to go on Google A2DG and you can hear all our reviews. And I just listed some of the reviews here. Yogan Rai, he is one of our best pioneer. He's in, think in Sikkim. He started his own freelancing company after learning from my courses. So he is a PCB designer. He started his own company and he's doing his fruitful job. Like he's helping the local Northeast India, if you like. And he's one of the dedicated student I have seen. He has taken up a lot of advice and guidance from me, and he started his own company. So likewise, there are people who have attended in the past, and these are all some of the reviews they have given to us generally. And you can read, go and read for yourself. So I'm just putting it out there for you all to read. Especially Naveen Sani, he recently completed our studies and he got into an intern straight away. And after intern, he will be placed into a full-time job, which he sent us a big nod. That happened only 2 weeks ago, I think. Yeah, 3 weeks. And like this, I want you, all of you, to be in this position. So that's why I'm giving you that offer. So please, please make use of that offer and go and purchase that. Okay, I'm just summarizing that what you all get. So if you register this in the next hour, you all you have to do is 14.99. And please do save that link. And please think about it and please talk to your friends or to your parents or other colleagues in the industry. And you can compare anywhere in this combination of Altium Designer, STM32 microcontroller, and C programming. I can't see anywhere they are providing for 14.99. You can be a Googler yourself. You can search. I'm sure you have to pay like 60,000 to 70,000 for the three courses. Yeah, but jokes apart. So please make use of that link and make through your purchase. Now I would like to continue with the slides and hear how to convert an idea to a prototype. So most of us, when we come to thinking about creating a project in our head, there will be plenty of ideas that will be flowing in and out, in and out. So whatever ideas you have, please note it down in a piece of paper or in a notebook, because that's always a good start for a project, any project. Then that ideas will start you to do all of these things that I listed. From that, you would be able to know what requirements you want or what requirements your clients are after. So from that, you would be able to choose the right processor or right microcontroller. I went in depth in detail to explain to you about the choosing the right processor in one of the modules in the courses you will learn there. I'm just giving you a brief outline of all about this. Then from that, you will be in a position to choose the development tool, like what microcontroller uses, what type of software it has to be programmed, etc. So you will know. And then you will decide whether the application needs a simple IDE or does it need a real-time operating system or just a simple program. You will be able to realize that. And then from there, you would be able to choose your packages and production tool, which when you learn our PCB design course, you will know about the packages and production tool. And then from that, being an embedded design engineer in the industry, you need to be good in software and also in hardware. Hardware is where the PCB design comes in. Software is the programming side comes in. So that's why I covered both. And in the PCB design, you will be designing schematic design. Whenever you design anything PCB, you need to consider these two. These two are the major consideration: design for test and design for manufacturing. DFT, and DFM. Because the product that you want to design, that you want to product, has to solve a purpose, and it has to be really, really useful. Otherwise, you may not be able to sell a lot. So that's why you need to do those two, DFT and DFM. That goes really deep in. Once you're in the industry, you will come to know all of those things. Then in the PCB design, you will also learn about layout, how to place each and every components. Like in the PCB that I showed, the layout plays a big role because of the connectors has to be the edge connector. Sorry, I put it back. I'll show you the layout design. So in this PCB, as you can see, the connectors I placed all in the edge, if you like. The input comes there, output goes there. So like this, you have to come up with your own layout to make sure what your clients or what application you're designing for. And likewise, so layout, I spend I think 1.5 days in explaining about how you can be very specialized in layout design engineer. And then after that, if you want to develop your own boards like I did, you can assemble and you can do your own debugging and testing before you go to a company and you say, hey, I have a design. Can you market this for me? And you can go for mass production. So, in a nutshell, you can have a PCB like this, but to have our safety in consideration, you can put a cover on top of this. That's the enclosure design. So, all you can see is only the input and the output, but this will sit in an enclosure. Like you won't see what's inside. So, that's the enclosure design. And then if you're really into manufacturing, you need to get some certification that is approved by CE, and that will allow your product to be sold in worldwide or in India. And then by doing so, you will start to design a lot of test jigs to cover each and every board or any devices that you manufacture to test. So this is how, in a nutshell, how the ideas are changed to a prototype. So if you simply follow these steps, you would be able to go to the other end and complete the whole design. Yes, I will. Rahul is asking a question. Sir, what are the factors to be considered while designing such PCBs? Okay. So first off, you got to ask the client or if you want to use for your own project, you need to check for the power consumption. Can I use it on a 3 volt or a 5 volt or a 9 volt? Accordingly, your components will vary. Because for low voltages, the components are a bit pricey, but for high voltages, the components are a little bit cheaper. So again, comes to your own project needs. But have power consumption as your major player. So think about how power. And the second thing, what are all the communication protocols that you need? Can you send that via serial communication, or do you need a I2C bus or a SPI bus or other communications, like how you're going to connect with the network, etc. So once you know all of that, then you can go into um, the PCB design course, which I covered. There I explain how to source components and how you can check for your own project. So then you can start to design in that area. Like while designing PCBs for high power transmission, high frequency signals, what are the main factors to be considered and to learn? Okay, that is a very good question, Rahul. So for the power transmission, always, I'm sorry, this is a bit more technical. The others may not be able to follow, but since you raised that question, the power transmission, you have to put in separate planes, like a power plane and a ground plane. You need to separate the power into multiple planes. So give a top layer power plane and a top layer ground plane, and to have a separate bottom layer power plane and a separate ground for the bottom layer. In that way, you don't have any crosstalks or anything that interferes the signals. This will help with the signal integrity when you do the DFT and DFM. That's where this power transmission and signal integrity will come. Yeah, think about dividing the power plane and the ground plane into few more extra additional layers, and that will help. Monica, yes, the less area is also a big factor because the more you pour silicon, the more you pour copper, the more you have to pay. So you need to keep as minimal as you can be and make your design as small as you can be. And depends on the PCB size you got to pay, which I have also covered in the PCB design class. So if you go there, you will know all about it. Thank you, thank you. You are welcome, Rahul. So I will move on. There is only one more thing I would like to finish, but I won't take long. But usually I used to give breaks, but this is I would like to show before you go because it's already. I thank you so much for your patience. It's already a lot of time. You've been sitting here and quietly listening to me. Thank you, thank you. I'll be fast with this. Okay, so this is the embedded development life cycle, if you like, or the embedded life cycle. And I have been part and parcel of the whole network of embedded life cycle. So in the industry, when you start to work in the embedded system, you will start to have with your software selection. There will be, if it depends upon a big team, there will have a separated hardware team and a software team. Simultaneously, they will select the software and also the hardware selection. The software selection will be what compiler you're going to use, and hardware section that will be what semiconductors, meaning what microcontrollers or what interfaces you need to use. So these things will be started in the first. And then people will move into whether they want a real-time operating system or a simple project or simple program. And then by doing so, in the hardware side, they will think about the hardware coverage. How long or how short has it to be covered? Like whether it needs hardwired network cabling, or for instance, this is a small example. Or can you connect to the cloud and can you send data? Likewise, in the hardware coverage, they will go in depth and discuss all this in details. Then comes in the software selection, they'll think about the networking protocols. What are all the networking they needed? And they will also be talking simultaneously with the project management team. Every time when they do a task, they have to check with the project team to see what's the budget is available, because networking protocol as such is you need to pay a lot of money to get a lot of services. So on the industry, it will be simultaneously. There will be plenty of sprint meetings. There will be plenty of program meetings. So he will learn once he get in the industry. But I'm just giving you the whole life cycle. I don't think anywhere you will see, but I would like to share this experience with you. Then in the hardware development, what they call as a board bring up. So they will simply draw something in a sketch in a paper, and they will visualize everything, what it's supposed to be, what sort of connectors, what is the power consumption, and what is the interface they needed. So that will come up in all the board bring up. And once they do this parallelly in the software development, sometimes some projects need Java support. For example, a login page, where if you want to do internet banking, for example, when you want to put in your login details, Java is really, really a big player there. So things like that in embedded as well, there is a connection with Java support, so people do that. And then comes the biggest graphic support, the front end and the back end, how the user can see and feel, and there is a lot of activities that supports graphic support. And then while doing so in the hardware development, they will do the board diagnostics. So they will make a ask the PCB manufacturers to make one of this, and they will start to do their initial manufacturing and test right from the start to eliminate all the functionalities. And once all of this done, then from the software side, they will run the whole code into an RTOS simulation. By this time, in complex projects, there will be multiple modules summarizing about 5,000 to 10,000 lines plus of coding. They have to put in a simulation to see whether they covered each and every functionality. In complex projects, there will be 500, thousands of requirements. So you need to go and address each and every line. So that will be the most effective simulation when they do. While they do that in the hardware, they do source level debugging, what stage they're up to. And once they finish all of this, then they move into integration and testing and tuning stage, where they build the rapid prototyping and then they do the real-time system analysis and debugging. Sometimes they use um, simulation tool like Protel Arcade and Protel simulation, and also MATLAB. They also use a lot of MATLABs in this real-time system analysis. And then in the software side, they will tune with the real-time data. They will put through some dummy data and see how well that system is functioning. And by doing so, there will be some memory leak detection, meaning it won't go and save in that particular location, for instance. So the software team will go and check and all of that. So they do a lot of memory leak detection in that. And then by doing so in the hardware, every time when you press compile and execute, it will give you a tracing. So you know exactly what testing you're doing and what is the result and what next steps you got to do. And once you finish all the cycle, then comes the deployment, which is the last end of any project. In the software, we call it as a post-mortem debug, and in the hardware, it's called in-field debugging. Post-mortem debug is nothing but once you send a product to your client, um, for example, if you want to update a firmware or a software for example, a TV, a smart TV you have purchased from a company, and the company or the brand they want to update to the latest firmware, they can do that over the air. All they need is they need your email and your um, uh, uh, for instance the TV IP addresses and all of that, and they can program that from their end. That's what post-mortem debug is. And in-field debugging in the hardware, they go and sit with the clients and they will go through function after function, and they will tally whatever functions they have. And if they want to be more functions added, then they come back to the team and then they start from software selection. So this is the whole embedded development lifecycle. And if you are clear with this, then please type clear. And I think this is the end of the session, I think. Oh yeah, only the last one is the applications. Thank you, Rahul. Yeah, that whole life cycle, it depends upon how skillful you are, how interesting and how you are at. There are some of my friends and even my students who do multiple jobs at the same time. So they do weekdays job, Monday to Friday, and weekends they will work on different areas of projects. So within about 5, 6 years, they can complete the whole cycle. Yeah, after 7 years, they will be landing into 25 lakhs per annum, 30 lakhs. So in that category. Okay, so some of the applications in the embedded system design are, you would see, these are all some of the things that I put in here: aerospace, automotive, infotainment, smart home, robotics, communication, audio, video, and medical imaging. There are plenty of other industries who use embedded systems. So that's why I wanted to start with these three courses, so it will be all beneficial for you. Um, uh, Hafiz is asking for a review of whole lecture. Okay, the whole lecture today is about, we started with giving you career pathways, and I think this is the last. Uh, okay, don't worry, I'll send you the bonus free ebook to your email. So I got your email, I will send it to you. And before I say thank you, I'll summarize for Muhammad Hafiz. He asked, we started with talking about the various career pathways for us electronic engineers. And then we went in depth in detail about embedded system design, about what are all the necessary skills that we need to have. And also, I showed you a little bit about the job market and how you can target to get any jobs. And also, I showed you the offer about when you go to our website, how people are paying more money, and I'm giving you because you are here on a special discounted offer. And then we come to learning about the embedded systems by itself in learning what is the definition and what are all the different classifications and what are all the different programmers and controllers out there. And then you learned about how you can convert your basic ideas to a prototype, and I explained to you the embedded development life cycle, and I given you touch base about the application. So this is what we learned. And tomorrow I would like to show you a small project in STM32 F411 at the same time, 10 a.m. Please come back and stay tuned. At 10 a.m. Tomorrow session will be a short one because it's a small project. But that will give you some insight about what you can develop on your own as well. So if you have any questions, you can type it in the chat box and I will answer. And please make use of that link that I shared and to make and go and purchase. I'll put it again here. Go and save this. And you can also purchase this by end of today. I think my team has expanded. Bala, the free ebook will be sent to your email. The registered email that you registered with Zoom, you will get that in your email. Thank you for that question. You are welcome, Hafiz Muhammad. Yes, Numair Ahmed, I'm sure my team would be help me to able to extend for the 3 days running. So please do serve that link. I'll check and I'll let you know. I'm sure you would be able to buy by Friday. That's how they will start. So um, they will extend until Friday, I think. So please, the rest of you, please save that link, and whenever you can afford, please do click on that and purchase. Why I'm saying that is because that will allow you to come and clear your own personal doubts in terms of the courses. Because the more your effort you put in, the more doubts you'll get. And also, I know that you are learning, and I'm happy to help. But a lot of people, they just come and ask questions without they don't do any of the homework, if you like. So that's why. Yeah, yeah. No worries, Muhammad Ahmed. Sorry. If you don't have any other questions, then thank you once again so much for tuning in and learning. I hope it was all useful for you, and I thank each and every one of you for your patience. I know it was a long session. Please go and enjoy that break from your screen. This is Arul Anbukarasu. I'm going to sign off if you don't have any other questions, and I'll see you tomorrow at 10 a.m. Indian Standard Time. Please take good care of yourselves, and I'll see you tomorrow. Hooroo for now. I'm going to close the chat and I'll see you tomorrow. And please do save that link for purchase. Thank you, Ahmed. Thank you, Rahul. I'd like to thank Suganya, Vignesh, Abjit, Pan, Patel, Raghu, Nandakumar. Thank you so much for taking that step to purchase. Mahesh Bala, thank you. Lalit, Jaychandran, Baresh, Bash, Badhu, thank you so much for attending again. Akash, thank you. Thank you so much, guys. And I'll see you tomorrow morning on a small project. I'm sure it will be interesting to you, and I'll explain to you how you can use it in STM32 microcontroller. Okay, see you all tomorrow. Have a lovely day, and I'll catch you tomorrow. Bye for now. I'm closing now.